today. I'm a software engineer by trade. I just recently learned what a CDO, what's it called, the network provider? Never mind. I really don't know much about energy yet. But I'm a software engineer, and nowadays I'm more of a DevOps guy, so someone who makes sure everything that happens between software developer creates code and the software runs somewhere securely in production. All these steps in between are to be dealt with. And yeah, I do this at a company called SprintEins. We are not that small anymore. We are already have been founded more than 10 years ago, have several locations, and we also have, why are we here? Well, because we mostly build software for enterprise customers, and they do have security requirements, such as please run different scanner tools that check whether everything is secure, and so on. So we have experience with that. And since we also strongly believe and want to contribute to the digitization of the energy sector, we are also contributing to projects, for instance, OpenSCD or the LF Energy project, Compass. So what I want to talk today about is, first of all, briefly introduce why do we want software to be secure. Then I will briefly explain what these dependencies actually are that we are closely looking at, and then look at a conceptual high-level approach for dealing with vulnerabilities in the dependencies. And then we go a little bit low-level at concrete tooling. And finally, before I give you very concrete recommendations, I make a brief analysis of over 32 projects of the LF Energy and regarding their dependency situation. So let's begin. Why do we want open source software or any software to be secure? Because you don't want to be in the news, briefly put, right? You don't want to be the bad guy who accidentally added some vulnerability to your code and it was bundled elsewhere and that site was affected. Like Log4j, it was in the national news everywhere. I don't want to be a Log4j developer. Looks bad. But of course, yeah, security is important, as you can think. And there are many doors or attack vectors into your software. Three very typical ones are, first, you have not correctly installed or deployed an application. It could have been deployed securely, but you didn't for some reason. Maybe lack of knowledge. Maybe you installed a software on a server and you forgot to activate the authentication mode. It can happen. Or you wrote code that is vulnerable either by accident or on purpose. What do I mean? By accident, well, you just write code and maybe it allowed someone else to stuff in some data. That's called an SQL injection attack. I'm not going into details, but in any way they can attack, an outsider can attack your application because you messed up. Or someone else, not part of your team, infiltrated your source code repository somehow, and they contributed malicious code, as happened with the XZ backdoor that I showed before, this news article. And finally, that's what I'm going to focus on today, is that your dependencies, in other words, other people's code, is affected by vulnerabilities, either the ones that you have declared or the indirect ones. I will go into in a second into the details of this distinction. And just to put it into perspective, I mean, many people here are writing open source libraries. They should hopefully become integrated into other parts of the ecosystem and run in all kinds of potentially critical parts of the infrastructure, and you want to avoid problems, especially in such a situation. And so with this talk, I want to help all of you to avoid common mistakes. So, these software dependencies, what I'm talking about all the time, why do we need them? What are they? What's the problem with them? So first of all, why do we use software dependencies? Because these software dependencies provide functionality to us that we then don't have to write ourselves. We take it from other people they have tested it hopefully, the quality is better, and so on. And it's faster and cheaper. That's the promise. How is it introduced? Well, a developer, the files that they put into the source code repository, like Git, is not just, I don't know, C#, JavaScript code. They also contribute these manifest files. They are just basically a list of all the dependencies you use, and they can also include which specific versions of the dependencies you use. And then the tools that you use on top of it, your package managers, they download all the dependencies from the internet and then they bundle up your entire application. And quite interestingly, there's a kind of a blow-up factor. Because what I just showed you usually contains the libraries that you put in yourself. Someone did this on purpose. But each of these libraries may have, again, other dependencies. So it kind of blows up. You get a tree of dependencies. And the blow-up factor, of course, depends on the programming language most of all, on the concrete project, on many kinds of things. And your mileage may vary. This is just a broad estimation, but you can probably figure Node.js and JavaScript projects have really the highest blow-up factor when it comes to dependencies, because they tend to create many small libraries, and other languages are better, but yeah, it depends on which context you are in. So to make it very graphically clear what the problem is, at the top you have your application, you declared the black boxes as your dependencies. They in turn are the indirect dependencies that they have declared, and if that thing is insecure, so is this one, and so is this one, simply by the law of transitivity. At least potentially. It doesn't have to be this way, of course. Maybe you are not calling any code, not any part of that code that is affected, but it could be the case. So, what you could say is, yeah, okay, we keep our dependencies up to date. How hard can it be? It's quite hard. There's a lot of stuff to do. So for instance, first of all, you need to figure out, do I even have, like, which of the many dependencies are updatable? Which ones have new versions? Then for each one that has a newer version, I have to test whether just updating that version maybe does it break anything in my application? And if it does so, then I have to fix it and update my code to make it compatible. And many projects and project leaders, or I don't know, product owners and so on, they might not see the immediate benefit of this compared to implementing feature after feature, so they prioritize it down. And that works until it doesn't work. And it doesn't work at that point when you already know by some way, maybe someone told you, that you have vulnerable dependencies in it and that you have a problem. Because now you have to drop everything, fix that dependency problem, the vulnerable, and then once you have fixed it, you can go back to business as usual, meaning that your typical velocity that you have, your delivery speed of 3 features per week, or I don't know, whatever you have, it gets a dip, right? You get negatively affected, your team is rattled. Yeah, that's something you might not want. So how can we address this conceptually? It starts by getting an overview. And once I have an overview, I have to do something with that overview and handle the dependencies. So the overview means there are actually 2 things to do. On the one hand, I use some kind of tooling to get the outdated dependencies. And on the other hand, I use different tooling to get the vulnerable dependencies. These are 2 separate problems. A dependency, any dependency, it could be vulnerable or not, or outdated or not, or both, like vulnerable and outdated. And just to illustrate this, I could have a library. It's completely up to date, but still it's vulnerable. Why? Because the maintainer stopped working on it. So, of course, it can happen that nobody fixes a known vulnerability for it. So what you would ideally do, if you can, is to take care of both. And the reason is there is a connection between outdated dependencies and vulnerable ones, in the sense of that the more outdated one dependency is, of course, the higher the chance will be that it also becomes vulnerable, and also the more work it would be that I have to invest to fix it. Because if I'm very outdated, I use, let's say, a version 1.0 and there's already 3.0s available, and only the security fix is only released for the 3 something line, and not for the 1 line that I am using, then I first have to get from 1 to 3 before I get this vulnerability fixed. And this is, again, involving more work and more risk. So suppose I have this list of outdated dependencies. What do I do with it? So first of all, I am throwing some stuff out which I don't want to look at any further. You have to define some kind of scope for your project, for your team, at which point you say, there are certain dependencies we do not want to update on purpose for, I don't know, some reason. There's always a reason. These are always like edge case looking things. If you do so, please still make a risk analysis in the sense of beam yourself forward in time and think, what would I do if it became a problem? What should I act on? Would we replace it if it were to become a problem with regards to vulnerability? Another thing is, now we have combed out, sorted out some of the maybe many dependency updates we found. Now we have to prioritize them, get some kind of order going. Maybe major versus minor is a good idea. Like you could say, major updates I will address first because they have the most risk. Other people think differently. They say, no, the minor updates I do first because they are easier, so I get the team motivated to start. Both are valid reasons. You have to try it out, which one works better. Similarly, the dependency types, like some dependencies are bundled into your application. They are also active at runtime on your servers, and some others are not. Some others are just used on the developer's computer, like the testing framework, maybe. And you could also say, the developer libraries, we prioritize them down, and the runtime libraries are higher prioritized. You could do this as well. And in any case, you need to convince the people giving money that you get some kind of budget to actually have time to look at these dependencies, to address them, to update them. You need to negotiate a budget for this, to do this also on a regular basis. And along with all that comes also a budget for better testing. The better your test suite is to figure out problems with a dependency update, like figure out a breaking change, the less manual work you will have over time. Because let's face it, these updated dependencies or dependency updates, they happen every day. If you have a JavaScript project, you will get new stuff every day, maybe several times a day. If you don't have automation, then you are forced to saying, we just do this once per month, and then we have this chunk of work once per month. It's manageable, but it's not ideal. So for vulnerable dependencies, keep in mind, I just talked about outdated ones. For vulnerable dependencies, you have a list of them somehow using some tool. Details soon. It's similar, but a little bit different. The similarity is I still need a scope. You could, for instance, use this a CVSS score. That's this number from 1 to 10, or also sometimes binned into critical, high, medium, low. That's the score that some security expert has assigned to the vulnerability. That's one input decision for you to take care of. But also other scores exist, like the EPSS score. That's a percentage, 0 to 100, indicating how likely this concrete vulnerability is exploited in practice. And combining these scores, you could say something like vulnerabilities with an EPSS of 0.01 and lower, we don't fix. Out of scope. No one's going to care. We have already 500 anyway. I want to get down to 100 and then continue on. These situations can happen. So that's your scope definition. Now you still need to prioritize. Same again, you can use the CVSS and EPSS scores in combination, maybe a weighted average or something to sort the findings that you have. And then also you need to allocate budget, of course, to update them, to fix them, and to regularly look at these lists. And now so far it was similar, right, to the outdated dependencies. But now the difference is with triage. Triage just means I have to address this vulnerability hands-on, concretely with something. Until now I've just determined which ones do I want to look at in which order. But now let's say I pick one and I need to do something with it. There are two questions you need to ask yourself and then try to answer. First of all, is this vulnerability real? Because sometimes the scanners, well, they don't lie on purpose, but they have incorrect detection routines, or maybe it's not really exploitable at all for some reason. Maybe it's not actually bundled with your application, and so on and so on. Maybe it's not a real problem. Then just note it down in your mitigation software and you are done. And the other thing to answer is, well, how easy would it be to exploit the vulnerability in your scenario? And if you have answered these questions, typically the developers do that, then you can choose one of three options what to do with that vulnerable dependency. Option number one, I think everybody has thought of this, well, update the version of that dependency to the most recent one where the maintainers of that dependency have fixed the vulnerability. Sure. If there is an update available, do that. Find the allocation, plan it in your project, in your sprints, or whatever you are doing, and get it done. Number two is, if that's not possible for some reason, replace the dependency, either with a different one that does something similar, which you have to research, or maybe re-implement the whole thing because maybe the functionality, it was just a small functionality and it's a huge library of which you used like 2%, and then you could maybe re-implement these 2% yourself. And lastly, if none of the other options can be done or are feasible within the next months or weeks in which you would have liked it fixed, then keep it, but then at least make a risk evaluation and think of the possible problems that could happen and what budget you are willing to put into it later if you have really a problem. So what you want to, ideally, if you can manage it, end up on the happy path, essentially. And the happy path would mean you have your dependencies updated anyway regularly. Whenever a dependency becomes vulnerable and the maintainers of it have issued a patch that fixes it, like let's say from 105 to 106, well, you just bump this one number in your file, in your dependencies file, and you are basically almost done. Because you just need to test whether nothing has changed, but nothing should have changed in a patch release normally, no breaking changes, and little work, little impact on your delivery speed, and so on. So that was all the high-level conceptual ideas, and I want to talk a little bit more about the tooling. To address both of these issues, namely outdated and vulnerable dependencies. Let's start with the outdated ones. I found and use two tools most of all, DependerBot and RenovateBot. They look through your repositories, they scan all the files in the repositories, they find dependencies which are pinned to specific version numbers or ranges, and then they make a pull request where that request just bumps the number to the highest available number. This is a screenshot of how it looks with DependerBot. This is a screenshot of how it looks with RenovateBot. It's mostly the same. There are a bunch of other tools, but I wanted to limit it to free and open source tools and not the bigger commercial ones. These pull requests also contain some helpful information so that you all don't have to always research it, like the change log of the dependency and so on. And a pull request, essentially, when you click on the Files Changed tab, as I said, it just bumps the number in that, the pinned version number in that file. So, if we look at DependerBot and RenovateBot side by side, what is the same for them, what's common, is that they both detect, in general, outdated dependencies and create pull requests for the directly declared dependencies, exclamation mark, not the indirect ones. What's also common for those is that you can configure a huge amount of things when it comes to the pull requests, how they should be formatted, how they should be grouped, and so on. Tons of stuff to configure. The differences are mostly nuanced. There are, for instance, the biggest difference I found was that the support for programming languages and package managers and files is a little bit different. I don't want to say either of them is better than the other. It depends. Like, for instance, if you work with C++, I saw some projects that do, then Renovate gives you a better support if you use Conan as a package manager. And DependerBot doesn't have support for it. But that's just one example. Essentially, you need to compare the features yourself for your language and use case. And of course, the platform support, like where do you host your code? Somewhere, GitHub, GitLab, GitHub, I don't know. With RenovateBot, you have the chance that your platform is supported with GitHub. If you use GitHub, then you might as well use DependerBot, which is, however, GitHub only. So, now about the concrete tools. I want to, in a minute, I will show you a big word cloud of tools, but before I go into these word clouds, just briefly, what do these tools need to do, actually? Each of these tools, they first need to create a complete list of your dependencies, indirect and direct, using some help, right? As an input, they will always have some kind of manifest files of your dependencies. If you know Java, for instance, this is the POM XML file, and there are many other examples. But they might even query the package registry, like Maven Central, or they might even call the package manager themselves on that machine where the scanner runs and determine the full list of dependencies. Each scanner is different. Once you have that list in some shape or form, you need to, basically for each entry, you need to query databases that contain the vulnerabilities. There are many of them, such as the NVD from basically United States, but there are many others also, meta databases that then include other databases and enrich them, like the GitHub Security Advisory, GHSA. Now you have the list of vulnerable dependencies, and that thing is not useful because you are running many of these scans, maybe per day, on different code bases, and now you have many files and lists, and what do you want to do with them? You have to stuff them into a platform that has a nice web interface that you can use to filter and browse and annotate and all that. So you need some kind of vulnerability management platform. Many of them also have licensing management included to, for instance, avoid that you accidentally include GPL libraries into your proprietary source or whatever grief you might have. Or maybe you don't want these funny open licenses that are not really open but claim to be, that have been pestering the open source community for so long. In any case, many tools exist, but since most of the projects here are on GitHub anyway, I will just focus on GitHub, because why should we discuss all the other stuff if this is pretty much all you need? So, GitHub has several features regarding vulnerability scanning that build upon each other. So I will now draw basically a 3-step graph from top to bottom, and I will start with the basic. The basic is the dependency graph that GitHub has. It looks like this. You can access it via the Insights tab. Every repository has this. and then go to dependency graph. It won't be rendered as a graph, why would you? It's a list for some reason. And what happens is that whenever you push code to your default branch of your repository, or you merge to that default branch, the server will immediately scan through all the committed files and, for many ecosystems, but not all, find the dependencies and immediately update this. This happens like a second after. So the next step is dependabot alerts. You need to enable this yourself in your repository settings, and it basically just compares all the dependencies in the graph with the vulnerability entries in the GHSA database and create an entry in your security tab and then the dependabot subtab. Only you, the maintainers, can see that, not everyone else on the internet. And if I were to click on this, one of these entries, it will show me some more details. And finally, we have the dependabot security updates feature, which is essentially just the automated creation of pull requests, like dependabot pull requests, for any dependabot alert that was found that tries to fix this vulnerability by an update. Because otherwise you would have to do that yourself. Like in the screenshot before, I could click here, right, whenever I see it, but essentially the last feature is auto-click. The problem is with GitHub, or the caveat, is this dependency graph. It's kind of a Achilles heel, the weak spot of GitHub that many people are not aware of. The problem is that GitHub's dependency graph does not correctly detect direct or sometimes just the indirect dependencies for some programming languages. For instance, if you are using .NET, Java with Maven, or Python with pip, then it will only detect the direct dependencies. Even though you have indirect ones, they are not part of the dependency graph by itself. You have to help. I will get into it how, but you have to do something. If you use Gradle, your dependency graph is empty. Not ideal. Solutions are either, you always need to read the docs for each language support, but either sometimes you can use log files. For instance, if you were to use Python, you could use Poetry, which generates a log file. These log files always contain all the dependencies, also indirect ones, and then commit this log file, and the dependency graph feature of GitHub happens to scan the Poetry log file. But it does not happen to scan the .NET NuGet log file for some reason. I don't know why. It's hit or miss. Read the documentation, read the small print thing, unfortunately. And the other solution is that there are a bunch of dependency submission workflows. These are ready-made GitHub actions that you can just add to your GitHub Actions YAML that you might already have anyway. And they will run certain tools that promise to generate the whole list of dependencies. And this list is uploaded via an API to the GitHub dependency graph. So now it gets juicy regarding the LF Energy projects. I did an analysis of these 32 repositories. Some of them already use something like Dependabot or Renovate, but I would say it's about a third, so not so much. I did this list looking at bigger projects that also have repositories where at the time when I did this in June, July, there was activity going on. So I did not look at repositories that haven't had a commit already back then in half a year. I mean, why would I? I wanted to look at active things. So these are the ones that I looked at. Maybe you recognize yourself in them. And since we, as an outside party, we don't have contributor permissions to any of those mostly. So what I did was to make my own GitHub organization, and I built also open source tooling that makes automated forks of all these different repositories in my own organization. also installs custom workflows that make sure that these forks are daily synchronized, because that's not a default feature of forks. GitHub never implemented this, you have to do it yourself. And I didn't want to click the sync button in 32 repositories every day myself, so I solved it in other ways. And finally, I invited the Renovate bot to my forks. And I also tuned the Renovate bot. I leave out the details, it's boring, but mostly to avoid some problems. And the result, just as an example, is a list of, for the PowerCycle core repository, just an example of how it looks like. Everybody can access this LF Energy project's renovation state. It's open, of course. And I also built open source tooling for visualization. I was curious to know, if you have Renovate in your repository for a long time, how have things developed? 3 months ago, how many open pull requests from Renovate did I have? How many 2 months ago? How many now? How is the trend going? Because Renovate doesn't show you that, right? You have to kind of scrape it yourself. And so I built a solution that shows the outdated dependencies. So it scans through all the pull requests, it parses the table in the pull requests that list all the dependencies inside it, and then it makes this graph. And now I sincerely hope that going into a live presentation will not end up in a complete mess. Yeah, perfect. So that's the graph. Whenever I point over some data point, I can see what the agenda means, right? This is for all the 32 projects combined, added up. So we can see we have, in all these 32 repositories, we have about 700 outdated, not necessarily vulnerable, but outdated components. And actually, the graph looks more or less flat. And yes, if you look at, looking at many of these repositories, let's say Compass Core, it turns out that these graphs are mostly flat. And however, some of the graphs are not mostly flat. Let's look at this one. You can see it's going up and up. I don't want to blame or anything, right? It's about just getting about the transparency of this whole process. Having outdated dependencies is fine. You can commit yourself and say we want certain updates not to be made on purpose. Completely fine. Not so sure about these security ones, but maybe they have been assessed and I don't know. And they are fine to be included in the project. So that's for the that's for the demo. Oh no, actually no, I wanted to show one other thing. I also looked at the DependerBot alerts. And sorted them in descending order. So I'm not gonna pinpoint the biggest ones here, but there are repositories with over 100 known vulnerable dependencies. I had to show this when at the keynote this morning it was advertised that projects are being helped with making sure everything's secure. But I believe that, but still it's interesting to talk about these numbers at some point. So feel free to look below the curtain afterwards if you like. And all this, what I showed, it's open source, the tool that draw the graphs, the tool that sets up the forks. So if you have in your own organization or teams, you want to know how would my repository look with all these Renovate and stuff, but I don't actually want to do it, I want to do this in a safe copy, you can. Just open these scripts, open these links from the presentation, and you can just adapt the name of your own fork organization and the name of the repos you want to affect, and then click run. That's all you need to do. So I want to go into a brief recommendations, really briefly. Number one is please always use a tool like this that finds the dependencies that you have. At least the ones that find outdated dependencies. You get the transparency. Even if you don't do anything with it, at least you know where you are at and you can talk with your team about it. Don't be discouraged if you have many findings at the beginning. It will become better if you really do dedicate yourself and find an approach. And it also builds trust in others. I mean, after all, if you build open source projects, you want others to use it. And others will more likely use your project if they see that you have this on track, that you know that you have tools like this that find dependencies and that you also close some of them and address them from time to time. For RenovateBot, I have also some introduction articles and tips and tricks linked. There are some problems you should not, like when you configure Renovate, you should not make some mistakes. Renovate by default finds only 10 pull requests and makes only 10 pull requests, but maybe you have more than 10. You just need to set a flag to allow Renovate to create all the pull requests, and you might want to set the flag. Also, Renovate helps you by flagging some of the problems. I think you cannot read it, by creating a GitHub issue that contains potential problems that Renovate might have when trying to scan your repository, like in this case, not having credentials to private registries. If it doesn't have credentials, it cannot look up the most recent version of the dependencies that you are referencing. Pin your dependencies, please, if possible. There are different strategies on how to do it. It depends on what you are building. If you're building a final product, maybe a web interface that is like not a library, use equals equals. If you are building a library, use semver ranges, because otherwise you would produce immediately conflicts with those projects that include you as a library, and they maybe include other libraries too, and they have conflicting equals equals things, and then the poor soul on the other end who has to fix it. This will always make your reproducibility better, and to find the most recent versions, well, you have Renovate. See step 1. So how can you do this poorly? By not declaring dependencies at all. I've seen this in one project. It's a huge bash script, and they download sources, and then they compile the sources by hand, and there's no version pinning, no package manager, even though there is Conan. Nothing is used like that. Or you can also declare dependency and then forget to pin them, and then Renovate cannot do anything with this, because what should it put there? It won't automatically put the newest number in it. So the depender.bot alert, the situation with the dependency graph I described before. The dependency graph is unreliable. You have to make sure it is reliable. See all the tips here. I won't go over it since we are close to lunchtime anyway. There are some funny caveats, like if you use custom GitHub actions to upload your own scan of a list of dependencies, then this snapshot may not be too large, or GitHub will crap out. Also shown in small font somewhere deep down, hidden in the API documentation. Since you are, especially if you build a library or a product, help others report bugs, not just bugs, report vulnerabilities to you. GitHub has a bunch of features documented here, how you can do this. One feature is just creating a README that tells people how they should contact you. The other one is actually enabling a nice GUI from GitHub that security reporters can use to have like a pre-made form to fill out when they want to report security vulnerabilities to you. Beyond dependency stuff, GitHub has a lot of other security-related features, unrelated to dependencies, but still interesting. For instance, scanning for secrets that you might have committed accidentally, scanning other things. Dependency reviews, also a nice feature that augments your pull request with nice to read and nice to understand information about changed dependencies in that pull request, and it will flag them if somebody added a dependency and it was already vulnerable at the point of adding it. So you might want to know this and then not accept the pull request. Yes, your repository itself that you have in the source code management platform, this also has a bunch of configuration options, and you can do lots of things wrong in configuring your GitHub repository, for instance. And the OpenSSF has created a nice guide. It recommends, for instance, the OpenSSF scorecard tool that you essentially point at your repository or your organization, and it scans through a bunch of anti-patterns that you, like how you could have incorrectly configured your GitHub repository, and warns you about those. And then can even put it as a nice list, or you can just run it on your machine, then it prints it to the console. This is also a means to build trust. If you have an OpenSSF scorecard in your project, this is really good for adoption. And last tip, whenever you use dependencies, you add new dependencies over time, over the years, please look at them closely. And there's tooling that supports you. For instance, SNUC Advisor or the website from Google, deps.dev. You just type in the dependency that you are about to add, and these websites will give you a nice summary of different criteria for you to look at. For instance, is this thing currently vulnerable? If not, has it been vulnerable in the last releases? How often have they released? How many stars do they have? How many committers? What's the licenses of the dependency? What's the licenses of the dependencies? And so on. So many other things. It even computes the scorecard for those repos, even then if they don't have it. So that's pretty much it. If you want, you can still ask questions. I'm fine with it, even though it's lunchtime. If you want to check out if your repository is affected from the list before, you can just open this organization and look at the results yourself. You can come to me, we can discuss it. I can add your repository there if you want to, and then we will collect data from now on. Also possible. And yeah, thank you for listening. Is there anyone who has a question? How many here have used RenovateBot and Dependabot? Yeah? Great. Please convince the others, the one that's sitting next to you. Yeah. You have a question?
Yes, I can try to just shout.
Fine with me?
I have a quick question when it comes to transparency of vulnerabilities. Have you ever had a concern that having the issues openly put out in the PRs in the repository would be a vulnerability by itself, as it being transparent about the fact that a version has an issue is worse than people not knowing about it until you fix it? What's your view on this?
Yeah. My opinion is, since this, when you ask RenovateBot to create PRs, you can also have them mark that this is a security-related PR, and this is public information, right? In contrast to just the Dependabot alerts, which are not public information, so there you don't have to worry. But yes, since this detection isn't working very well in my experience anyway, I would just deactivate it in RenovateBot and have a direct look at the GitHub Dependabot alerts, rather than have RenovateBot generate these. To avoid that you have a public display of vulnerable dependencies that could be updated. Yes. Yeah?
I need the microphone. I'll just shout.
Go for it, yes.
So I run into situations where I'm trying to get all of the modules that we're depending on, all the packages we depend on, up to date. You run into conditions where they conflict with each other and you can't update.
Yeah.
And you end up, and this happens with pretty well-known packages, you end up essentially not being able to use one or the other,
Mm-hmm.
because one of them is up to date and it's incompatible with the other.
Yeah, yeah.
Is there like, and essentially the package managers just bail. They just refuse
Yeah,
to do
yeah.
anything. What's your general recommendation of what to do? Do you have to like figure it out for yourself, or is there
Yeah.
a process?
Normally, yes. I mean, of course, you can try to talk to the maintainers because,
I'll just say AWS, not Apple.
yeah, yeah. That's one of the edge cases before that I didn't want to go into when you define your scope, and your scope, of course, is fluid. You update it all the time, and then suddenly your scope becomes, we are not updating this library because we just can't. Our package manager will go bust, and we just can't, and we are stuck. And other than replacing that dependency completely, yeah, I know. There's no silver bullet I could hand you on that platter. Sorry.
So that, I mean, what ends up happening is you just end up always having that vulnerability. There's nothing you can do.
Well, choose, if in doubt, replace that dependency that is easier to replace. Yeah. It's not nice, I know. Yeah.
Odo Core or AWS CLI?
Yeah. Yeah. Tough. Okay, I think we've come to a close. Thank you, everyone. Enjoy lunch.